So today, we are going to learn monitoring, so table partitioning, and we will learn. So we'll learn about loading and moving data. So these are the three topics we will learn today. Okay, these are the three topics we will learn today. Okay, so monitoring is a one of the ongoing DBA job. Like yesterday, we learned about maintenance. So maintenance is also an ongoing job. So you might be doing the maintenance very often. Okay, you might not be doing the configuration change very often. You might not be installing Postgres very often, but you will be doing maintenance very often. In the same way, the monitoring also, so you will be doing very often. So where to look for the information? As a DBA, you should know what's happening on the server. So how the server is performing, how it is working. So you want to know all these things. So as a DBA, so how you can do, where you can look for information, how you can extract the information. So the main source of monitoring information in Postgres is the stats collector process or collector usage statistic. The usage statistics is the main source of what we say means monitoring. Statistics subsystem tracks the activity on the server, information like number of rows in the table, like dead rows, you know. So number of dead rows, number of live rows, when analyze is done, when vacuuming is done on the table, how many inserts done. So that type of information is captured. It calls to the it also counts the calls to the user defined functions and stored procedures. So you can, if you don't want, you can turn off the system stats collector process. So that is a utility process, but you can turn it off. So if you don't want, you can turn it off. Okay. So statistic collector subsystem adds some overhead to the query execution, obviously, because it is watching. Okay. The stats collector is watching the query execution. So that's the reason, any monitoring will have some overhead, at least a small overhead. Okay. That is what, the stats collector subsystem is about. How we can configure or control the stats collector subsystem? You have a parameter called as track activities. Let me log into the lab. Okay, the stats collector subsystem are, the stats collector. Uh, so it is responsible for most of the usage statistics, which are helpful for the DBA in monitoring the server. Oh, here we are in the Postgres user. So this track counts on. So this controls the stats collector process. This controls the stats collector process. If you don't want stats collector process, you can set it to off. Track activities, track counts, track functions, track IO timing. So that is also on, but show track functions. So it is not on, and track IO timings. And it is also not okay. Track what is say IO timing, not timings. Okay. So let's go here. So that is also off. These are the parameters we have with which we can control. Okay. So we can control using these parameters, we can control so our stats collector process. Okay. Okay. So these are the parameters you have to control stats collector process. Right now, it is tracking the counts, that is how many inserts are done, how many updates are done. So it is tracking the count, it is tracking the activity like, so the vacuuming, auto vacuuming, manual vacuuming, or, analyze command. So it is tracking the activities and it is tracking the counts. But it is not tracking the functions and IO timings also right now. Stat collection interval is 500 milliseconds can only be, so you cannot change this collection interval. So it is half second, 500 millisecond is half second. All the collected statistics are stored temporarily in PG stat temp directory in the data directory. So we have this PG stat temp directory in the data directory where, the statistics are saved temporarily. If you stop Postgres service, at the time the statistics are persisted to PG underscore stat directory. These two directories contains the statistics per database and some global statistics also saved here. So you can go and check out those directories. Exit from here, CD 14 data. So you can check here, there is a PG underscore stat underscore temp directory here. PG underscore stat directory where, in temp directory, while the server is running, the statistics are persisted to temp directory. And when you shut down the server, so one of the last activity is it will save the statistics from the temp directory to the stat directory. What we have is nothing. So per DB, you will have this. So you can see this. Each DB have their own, what is it? DB1 is template 1, DB0 is template 0. 13748 is Postgres. 16390 is our MyDB. So per DB, there is a file, statistics file maintained. And another statistics file which is maintained is global.stat file. So that is for all global statistics like, the background writer activity, the checkpointer activity, they are also monitored and saved in the global file. So these are the two directories. So where, the statistics are saved. And whatever we see, yesterday we have seen that, PG underscore stat underscore user underscore table, that is a view. And from where it is getting the source data is from that directory, from that directory. Okay, so how this is how, those four parameters controls the statistics. So you can enable more of them. So you can disable activities. If you say track active, if you disable track activities, the whole stats collector subsystem stops working. And if Postgres does not collect any more statistics for, monitoring purpose. So it is not recommended to, disable that. So count, sorry, track activities. But if you want, you can do it. track activities, track counts. If you disable them, so the Postgres will not be able to collect, or will not be able to know what is happening. And that also impacts the auto vacuum. Auto vacuum is completely dependent on this subsystem. If this subsystem is off, the stats collector is off, your auto vacuum is also off. It also does not work. So where to see the statistics? PostgreSQL, there are many stats views. Yesterday I have shown you there are so many stat views. So Postgres provides, those views in the catalog schema, in the catalog, to so that you can query them and you can know them what's happening. So for almost all the objects, you have the views. Like for user tables, you have the view. Indexes, you have the view. So for almost all the objects, you have the views. So the PG stat directory, the PG stat directory where the statistics are permanently saved. So that is in the data directory permanent. However, the temp directory, so PG stat temp directory, where the statistics are saved first before moving to the PG stat directory. So that can be changed. The location of the directory can be changed and located outside the data directory. Okay. So there is a parameter called as stat temp directory. You can change the stat temp directory. So with that, you can set the new location for the stat temp directory. So you connect here and you check out for the option. So stat temp directory. Stat temp directory. Looks like I had given directory stat temp directory. Okay, stats temp directory. Sorry, it is not stat directory, but it is stats directory. So what I am doing is I'm missing here an S. So this is what the value now is. So you can change this to any other location. So you can move the stats temp directory to a faster medium like SSD storage and all, because statistics are written every 500 milliseconds, that is every half second. So that's the reason, if it is on a faster medium, so you will get some performance benefit. Dynamic statistics. There are dynamic statistics, there are collected statistics, and there are global statistics. Dynamic statistics means how the things are happening right now, what things are happening right now. So what is happening on the server right now? So that is what the dynamic is. Okay. And collected statistics means, like how many inserts are done, when the vacuum was done on the table. So, that is what, the collected statistics are. Dynamic statistics means currently who have logged in. So that is dynamic. Who are processing the logs or who are waiting for the logs. That is also dynamic. Okay. How many guys are doing SSL connection? So that is also dynamic, right? That information is also dynamic. So as it is happening on the server. Okay. So the main view from where you can get this is PG stat activity view. This presents the information about the currently what's happening on the server. Who have logged in, what they are doing, what queries they are running. Yesterday we have seen yesterday we have seen it will show for each user, for each session, whether that is explicit user session or the implicit sessions started by Postgres. It will show one row in the PG stat activity, and that row also includes what is the current status and what is the current activity. So that particular connection is doing. So each and every connection will have an entry in the PG stat activity. Okay. This is the main view to know what is happening currently on the server. PG stat SSL, I think you guys should be familiar with this one also. PG stat SSL is where if any user does a SSL connection, so it will show that this user is doing the SSL connections. The GSS API authentication is a Windows authentication. If any user is doing GSS API authentication, that is Windows authentication, so then it will be, so there will be one entry in this particular view. The community edition by default does not support GSS API authentication, but the enterprise edition supports. There are progress views. For example, you have an index, you're creating an index on a very large table. So it takes a lot of time for that. It takes about maybe about 5 to 10 minutes to complete the execution of the index. Okay, sometimes even more also, if the table is very large. In the same way, vacuuming, or yesterday we learned about the cluster, right? So when you do these activities, so it may take some time, like creating an index, vacuuming a table, particularly vacuuming full takes a lot of time. And the cluster, it also takes a lot of time on large tables. So generally what happens is, if you want to know the progress, how far, it has completed. So you can always, use these views. Progress views, PG stat progress create index, PG stat progress vacuum, PG stat progress cluster. So it will tell you if any of the activities happening are done by the other user. So they report the progress, how much work is done and how much more work is there. So these are the dynamic views. So from where we can see what is happening right now on the server. Apart from that, we have collected statistics. There is a PGStat database view, so which collects the database level statistics, and there is a row for each database in that view. If you have 4 databases, there will be 4 rows here. So for each database, there will be a row here. So PGStat user tables, we have seen yesterday, there will be a row for each user table, there will be 1 row. So we also have exact user table. Okay. So both are same. PGStat user table or PGStat exact user table. The only difference is the currently ongoing transaction. If there is any currently ongoing transaction on the table, okay, the PGStat user table does not show that. Only completed transactions it will show. So whereas exact user table, so will give you the details which includes the current transaction plus previous transactions. PGStat user indexes 1 row each for indexes created. So this is the great place to know the usage of the index, how many times the index is used. If it is not used, so it will be how many times index is used, so that will be 0, and with that you can determine whether the index is never used, or you want to retain it or you want to remove it. To track the user tables IO, that is IO activity. So you have a table PGStat IO user tables, but you need to enable the IO tracking first. So that is not enabled right now. Track IO timing is not enabled right now. So if you enable track IO timing, so you can also collect, the IO activity for per table basis. IO latencies per table basis. So PGStat IO for your user sequences, and there is a PGStat functions. So that is for each function, how many calls is made to the function. So that will be there for each function, there will be 1 row. So which tells you how many calls are made to that function. So you also have exact user functions. So there are 2 more views, PGStat archiver and PGStat background writer. So these views tells us about, these are, the global statistics views. So these will tell about, the background writer process and archiver process. The background writer process also tells us how the checkpointing is happening. Okay. This view also tells us, about the checkpointing also. Let us see about the background writer view. PG underscore stat underscore background writer. So these are some of the columns we have here. The most important columns are the most important column you need to look into is these 2 columns, the first 2 columns, checkpoints timed and checkpoints requested. So REQ is for requested. So timed checkpoints. So the checkpoint timeout is 5 minutes. Right now, the checkpoints are happening every 5 minutes. They are happening in the background. The checkpointer process sleeps for 5 minutes and wakes up and does the checkpointing. Okay. So the columns here, checkpoint timed means how many times you have done the means the server has done the time checkpoints every 5 minutes. So that is timed. How many checkpoints happened so far? Timed checkpoints. And checkpoint should happen timed on time, right? So it should not happen before the time, right? But sometimes it is required to perform the checkpoint before time also. So when it is done is when the buffers are the clean buffers are not available, so it will perform the checkpoints before time sometime. If a transaction has started and the clean buffer is not available in shared buffer, so there should be some, so it has to write some dirty pages to make room for the new transaction. So that is what the requested checkpoint. So the connection, the user connection or user session has requested the checkpoint. Okay, so that is the requested checkpoint. We also have a checkpoint command. Checkpoint command performs the checkpointing on demand. Okay, so so that is also requested checkpoint. This is a requested checkpoint. Checkpoint should not be requested. They should happen every 5 minutes or whatever the time the DBA has set. Right now it is 5 minutes. Whatever time DBA has set, checkpoint should happen at that time. Okay, at a fixed time. But sometimes the DBA may perform the checkpoint, that is very rare. Or the most common thing here is, a transaction starts and finds that there are no clean pages and it will request a checkpoint. That is the more common scenario on busy servers. So that is a requested checkpoint. So, the requested checkpoints are bad. If there are many requested checkpoints happening on the server, that means, you don't have enough shared buffers. It is time to increase the shared buffers. Okay, it is time to increase the shared buffers if there are more requested checkpoints. Select. From PG underscore BG writer. Okay. So, the requested checkpoints are only 10 compared to, so compared to, 2031, 2231 checkpoints, which happened timed, that is, every 5 minutes. So that is okay because, that is okay. So there are no more requested checkpoints. So, so most of those checkpoints generally happens when you run the checkpoint command, or you are doing transactions and clean buffers are not there, so it will initiate a checkpoint in the background. So, and the third thing is, you are doing certain activities. So, like, you are taking a backup. So, such things. So then also, checkpoints are performed. Okay. So these are all requested checkpoints. So every 5 minutes, the checkpoint which occurs is a timed checkpoints, and always you should have more time checkpoints and a negligible amount of requested checkpoints like this. If your requested checkpoints are so huge and they are more than the time checkpoints, then it is time for you to increase the shared buffer size. So that indicates the shared buffer is not adequate on the server. So that is about
A checkpoint request is showing us that how many transaction is waiting for buffer. Is it like that?
checkpoint requested means not waiting for buffer. How many times a transaction has requested a checkpoint before scheduled time. So what happens if the transaction does not find the clean buffer? It will request a checkpoint. Got it?
Okay, okay.
So if the transaction is starting and there are no clean buffers in the shared buffer, so the transaction will initiate or request a checkpoint. So that should not happen. So if it is happening, that shows inadequate shared buffer, right?
Yes.
So we have our PG admin here. So any database you expand, go to the catalogs. So go to the PG catalog and go to the views. And if you come down, you have these views. PG stat activity, PG stat all indexes. All indexes means system and user indexes. So PG stat all tables means system tables and user tables. Archiver. So tomorrow we will work with archiving. So, so tomorrow we will see how to back up and recover. So we will be learning about archiving also. So archiver related statistics will be there. If you want to know if the archiver is running fine or there are any problems, you can see in this. So background writer, just now I have said. So stat database, statistics related database conflicts, like so deadlocks, locks, there is a table for, there is a view for that. So Postgres analyze, statistics related Postgres analyze, stats related base backup. So progress, these are, if the backup is running, you want to know the progress of the backup, right? Sometimes backups runs for an hour's time. So you want to know what is the progress. So from here you can know. So these are all progress views, progress vacuum, progress create index, progress copy. So copy is exporting the data to CSV. So progress cluster, yesterday we learned about the cluster, right? Base backup stat analyze is, the analyze command. So these are all, the statistics. So particularly the user table, user indexes, these statistics are very, very helpful for us. Okay. In the user index, PG stat user indexes. So one of the thing is you have the index scan. How many times, so index scan was done. So this tells you, whether the index is used or not used. So if it is zero means if there is an index and that index is never used, my IDX, it is never used so far. So yesterday we have created this myIDX to what we say means so do the clustering. So we have created it, but so far, so we that is not used by any select query. Okay, so it is not used by any select query till now. So that zero indicates here. From here you can find out efficiency of the index. So if it is never used, better you can get rid of that index also. So we also have statistics about the val. So val statistics are there. So how much val buffer size and other things it will indicate. Okay. So these are the statistics objects from where you can see the statistics. They are also, the statistic IO statistics for user tables, IO statistics for sequences, IO statistics for index also. So you can also examine those views to know what is happening. Okay. So right now, we didn't enable. So, but if we have enabled, so here it will write. So how many reads are there? How many hits are there? So that means, read means how many times it has to read from the disk and how many times the data was available in the memory. Okay. So index block reads, so index block heads. So heap block read means, data block reads and heads hits. So, and index reads and index hits. So, and you also have toast read and toast hit. So this toast is something, very different in Postgres. So we didn't discuss about the toast earlier because there is no need to for DBS to know about the toast. But however, so the Postgres has one requirement, that is the entire row should fit in 8 kilobytes. Okay, that is the requirement. So entire row should fit in 8 kilobytes, one page. So if you have a large rows, big rows, what Postgres does is, so it will split that rows and it will save the row, save the extra information in a file, data file called as toast. So there is no need for a DBA and the developer to know about toast because they work transparently. So they work transparently. You will never feel that there is something called as toast. So all your large objects will go into the toast transparently. You are inserting into the table. So because the Postgres detects it is a large object, it will actually save it in toast. Okay. So that is what the toast is. Okay. So here we have, so block reads and block hits. So how many times, it is able to get the data in the shared buffer, that is hits, and how many times it has to read the data from the disk, so that is the read. So these are the things. So these are the things. So you will get from the IO. If you enable the IO, so you will get more detailedly these things. Right now, the IO is not enabled. So the stat views are the one from where you can see all the statistics, collected statistics. Whether it is, the server level, that is, the instance level statistics. So, or, the table level or index level statistics or database level statistics. All of them are visible from that stat views. Okay. So that helps a lot in monitoring the database server. So Postgres database server. Okay. Apart from that, monitoring so involves watching the error log. So, we also have error log. So already we have seen the error log, right? Exit. So we have the current log file. It is a text file. So, this is Wednesday log. Today is the Wednesday. Wednesday log is today's log. Go into the log directory, and here you find this Wednesday log. Okay, this is the current log. You can also do ls-ltr. So that also tells you. So, so this is the current file. Okay, the last file is the latest used file, right? So, that is the current file. Okay, so the Wednesday log is, so today is Wednesday, so we have, so whatever activity is happening, so it will record that activity in that. So these error logs are also a good source of monitoring Postgres. Also, Postgres allows you to do some configuration, means some adjustments. So Postgres allows you to do some adjustments for what information to be captured in the log. So we will see so what adjustments or what configuration we can do to get the information we want. So log min messages. So this is one thing so called as log min messages. So that is warning. Log min messages is like warning for us now. Okay. What it means is, so what it means is, so any message with a level of warning, so will be written to the, okay, to be written to the log. Any message which is higher than warning, severe than warning, that is also will be written to the log file. The messages which are not very severe means less than one, severity is less than warning, so they are not written. And if you want to know what are these severity levels, they starts with debug 5. Debug 5 is the lowest severity level, and panic is highest severity level. So generally panic means server crash. So Postgres service is stopping. That is what the panic level means. So fatal level means, the user is denied access. Okay. So that is fatal. Log means, so log level means, so that is messages from, stored procedures, functions. So can be written into the log file using the log level. So, error level means, a statement has caused error message due to syntax error, unavailability of the object. So that is error level. Warning level. So, so right now, our level is warning. Warning means log min messages. Warning means, so it will write all warnings. It will write all errors up until panic messages. It will write all messages from warning and above. So you can set this to debug 5. So you will get a lot of log. So sometimes it is required to, capture the log. So if you are facing any issue and you are not able to understand, so what you need to do is you need to increase the log min messages. So, so it will write more messages, more diagnostic messages about that log, about that error condition. So if you increase that, means if you decrease the severity levels. Log min error statement controls which SQL statement cause an error condition. So whether, we have to record the error condition, any SQL statement which causes the error condition. So again, you have starting from debug file till panic. Okay. So, and the default is error. Any SQL statement. So select star from EMP or any other insert, update, delete, any SQL statement you have executed and that resulted in an error means that statement is recorded in the error log file. So you can find out. So what are the error statements which are done by users? So log min error statements. Right now it is error. So if you want, you can also again check, go into the warnings also. It also records all the SQL statements which are executed by users, which resulted in warnings, errors, or even higher. Okay, log min duration statement. Okay, this is one of the important, what we say means. So one of the important uh, parameter which should be enabled on new server. So which should be enabled on all new servers, or at least, which should be enabled whenever there is a change in the application. So sometimes, they will apply a new code in the application. What it means, if they apply the new code in the application means they may introduce new queries into the application. And generally those queries will definitely may cause the problems, right? So whenever there is a change in the application, the new queries are introduced to the Postgres, and those queries, if they are not optimized, they will run slower and cause issues. So the log minimum duration statement, so if it is set to a time, so then, so time duration, then what happens is any statement taking that much time or more than that time will be recorded as slow running statements, slow queries. So you can catch all slow queries. So using this log min duration statement, you can set it to a time duration in milliseconds. Okay. Log min duration statement. So right now it is -1, that means disabled. So right now it is not. If you want, you can set it to some milliseconds. It is, the value is always milliseconds. So if any statement, any select statement you ran and that took, so that many milliseconds you set here or more than that. So in either case, it is considered as a slow query and it will be written in the log file along with the query text, so that you can find such queries and you can try to optimize such queries. So this is one of the way of filtering slow running queries on the server. Log auto vacuum min duration. Auto vacuum runs, right? Sometimes it may take a lot of time. So if auto vacuum takes a lot of time, so some people may be disturbed. So we want a method to, know, so at what times, auto vacuum is taking longer duration. So you can enable this log auto vacuum min duration. Okay. So this will, so this will log any auto vacuum activity which took more than set time or more than set time. If the activity has completed below the time set, it is okay. So if the activity took the set time or more, so then it will be considered as a issue and it will be written in the log file. So later on, you can check the log file and see, so how the auto vacuum is doing. So this is one of the thing you can use to determine whether auto vacuum is running longer time or it is running within the expected time. Log checkpoints. Every time checkpoint occurs, it will log the details of the checkpoint, log connections. So anybody try to, connect. So anybody connects to the server. So they are, that will be written to the log file. So this is one of the good way of monitoring who is connecting to the server. So log connections, log disconnections. So if anybody has disconnected from the server, that information is written in the log file. Anybody has connected on the server, that information is written in the log file. Okay. So that is what, the log connections and disconnections are. So with that, you can enable some kind of, built-in auditing. So you can keep an eye on who is coming and who is doing what. So log duration. Okay, log min duration statement, right? Earlier we have seen this. So log min duration statement. So that means, whatever time duration you have set. So let us say you have set it as, 800 milliseconds. So any query which is taking 800 millisecond or more is considered as slow. And any query which is completing below 800 millisecond, within 800 millisecond, that will be considered as good. So the slow queries are written to the log. So that is log min duration statement. So here, you are giving a threshold. The log duration statement, that is true or false, you are not giving any threshold. Even if the query took just 1 millisecond also, it is written that this so and so query took 1 millisecond. So this is also one of the way you want to track the query timing, especially when the application is deployed newly or a application is patched recently. So, okay, if your application is, having a new version or changes in the application, that always leads to introducing new queries. So the new queries may not be optimized. So in such case, always enable that log min duration statement. Log duration also you enable. So log duration means, even if the query is taking 1 second, it will be written. So and so query took 1 second. So that way you will come to know usually how much time the query it takes. Log waits. So Boolean, that is also, if any user is waiting for the logs, so, you can, so, so there is a deadlock timeout parameter. So there is a deadlock timeout parameter. If any user has waited for the log more than the time set in deadlock timeout, so it will be written in the error log file. Log statements. So you want to log every statement. So every statement which is happening on the server, so you can, enable this log statement. So you have to set it to some values. So which statement? All statements, are only modification statements, are only DDL statements. So the default is none. So you can set it to DDL, then any DDL statement anybody does, so that is recorded. So and so DDL statement was executed. Mod means any modification, whether it is DDL or DML modification or DCL, any modification that is recorded. All means all statements, DDL, DML, everything. Modification, even select statements also recorded. Log temp files. So you generally, so what we have is a buffer named, work memory. Every user connection will get a work memory. That work memory used by the user to, to sort, if the sorting operations are involved in the query execution, that work memory is used. By default, it is 4 MB. So what happens here is, so if the work memory is inadequate for very large tables, sometimes the work memory is inadequate. So in such case, it will create temporary disk files to sort. Okay, that is where the log temp files, if it is okay set to a size in bytes. So what happens is, if the temporary table is of that much size or more, so it will be recorded which query has caused the temporary file to be created. So that will be recorded and you can track those queries and you can work on those queries to know what is wrong with them. Okay. So that is about, our error log file, some of the important parameters in the error log file. So which you can set. Database log monitoring. As a DBA, time to time, you have to keep an eye on the logs. Already we have seen some log monitoring. So you can configure the error log to write, okay, log weights. Okay. So you can set it to true. It is a Boolean. You have to set it to true. So if you set the lock weight to true, so it will write the lock information, which user is waiting for the locks. So it will write the lock information. That is something like lock monitoring. Apart from that, so as it is happening, you can also monitor the logs. So this is something which is happened and it is recorded in the log file. That's a history. As the logs are happening, you should be able to see that, right? So that is where the database, this topic is helpful. So what you can do is, there is a pg stat activity. So this view is there, pg stat activity, which tells you how many connections are there and what queries those connections are doing right now, what queries they are running right now. PG stat activity view. So it contains that information. So, the query which is waiting for the user which is waiting for the log is also a session, and the user who is currently holding the log is also a connection. So both that user details will be there in PG start activity. Okay. The only thing is it won't be there uh, is, whether they are waiting for the log or whether they are holding the log, that information will not be there. Precisely that information will be available in PG underscore logs view. The PG underscore log view contains, so it will contain, so all the log related information. Okay. So like, who is holding the lock right now, who is waiting for the lock right now. So both the information will be there, both the the victim and also the one who is holding the lock currently. So both that information will be there in PG logs. Okay. So these two views you can use, PG stat activity and PG logs view, to know currently which users are victims and which users are holding the logs. So there are some other functions which are helpful for us, like PG blocking PIDs. So if you are a victim session, that is you are waiting for the log. So you are a victim session and you want to know who is blocking you. So who are your aggressors or blocking guys? So that is PG blocking PIDs if you give. So, and you give the victims session ID. So victims, backend ID, that is PID. So then who are blocking that victim, okay, session. So list of backend PIDs are given. So these are the users who are blocking this particular user. So that is the blocking PID is a function. Okay. PG cancel backend, that yesterday we have seen, you can cancel or terminate the current query of the user. and PG terminate backend. So this will end the session of a user. If the user is so erratic and you want to terminate that user, so you can always use this PG terminate backend, and within the brackets you have to give the PID, and where you can find the PID of the user. So from PG stat activity and also PS command, both of them will give the PID of each backend session, user session. Okay. So the same PID you can use in the blocking also. If it is a victim's PID, it will show which are all users currently blocking this victim. Okay. So these are the two views we have for monitoring, and these are the three functions we have for managing. Okay. These two functions are managing the logs, and this function is still monitoring the logs. Okay. So there are certain, so there are a lot of columns in PG stat activity. Some of the important columns I will tell. Other column description I had given here. So the connection, each connection, user connection comes and connects to a database. Always remember, every connection is connects to the database. So in every connection, every session, one user is involved and one database is involved. User connects to the database, or database accepts user connection, whichever you put, but both are involved. One database and one user. Okay. So to which database the user is connected, the PID, that is the process ID, operating system PID. So with this PID, you can find the blockers. With this PID, you can terminate other sessions. So this is what. So leader PID, if sometimes Postgres will do parallelizations for select queries. So in that you have three four uh, what we say means backend connections are created, processes are created to execute the same query. One of them is also leader PID. So generally it will be null for single, so what we say means worker PID. So if the parallelization happened, so there are group of workers which performs one task. In that, one of them will be leader. So you will find which is the leader's PID. So that is only for the select statement mostly. So use sys OID means the user's OID. Use name is username. So what we need is database name, the PID, and the username. So application name, so this is, tells, whether it is PSQL or it is PG admin. So client address, client host name, client port, backend start time. So when the user connected, so that is backend start time. Okay. Exact timestamp. So the exact time means when X means transaction here. Exact means transaction start time. Okay. So exact means transaction, the current transaction start time. So query start time, the current query start time. So change timestamp when the status of the query was last changed. So event type. So, so wait event. What is the wait event? Okay. State. What is the state? So state can be active, idle, idle in transaction, aborted transaction, fast path to function call, so disabled. So these are, the states we have for each, what we say means, so each connection. Okay. Each connection may be active, may be idle, so maybe in transaction, maybe in an aborted transaction. So maybe disabled. Disabled means, track activities is disabled. So you are not tracking user activities. So if user activity is not tracked, all these stat tables won't work. Okay. So query text is another thing which gives you the entire query. So up to, 1024 bytes. If your query is longer than this, it will be truncated. However, if you are using longer queries, so you can estimate what is the size of the query in byte. One byte is one character, including a space is also byte. If you say select star from EMP, so that means, six of selects, one space, seven, and star is eight, one space, nine. So select star from is four, that is 13, nine plus four. So likewise, you can count how many characters it got, and you can set track activity query size. You can increase that from 1024 bytes to, like 2000, 3000, 5000 bytes. So if you are doing longer queries, otherwise, the query will be long queries will be truncated. If you have a query which is very long, so that will be truncated after 1024 bytes. So backend type is also there. Backend type means whether it is an auto vacuum, whether it is a logical replication. So whether it is a, if it is a background, so background writer. So client backend means, this is something. So from a client. So if it is a background writer, it is a parallel worker, replication worker. So these are all, others. So check pointer, startup, wall receiver, wall sender. So in that, client backend is, the user connections, backend type. So PG log has these columns, log type. Okay, database on which this table exists, which is logged. So relation, the table name, okay, page number. So so which page which is targeted. So tuple. So which tuple which is targeted. So there is a transaction ID and virtual transaction ID. So all the write transactions like insert, update, deletes will have transaction IDs, including alter. So any data changing will be done under a transaction ID. Virtual transaction ID means any read transactions. Okay. So that is virtual transaction ID. So class OID, that is, the class ID. So that is, OID of the system catalog. So that is, log target, that is, the OID. Okay. Object ID. So, and the what you need to do know is the PID. PID is the same PID, backend client backend PID, or the connections PID. This PID is same as the PID in the PG stat activity table. So you need to join the PG stat activity table and this PG logs table on this PID column. Okay. So, and there is a thing called as granted. Granted means if the lock is granted to the user, if it is true, it is a boolean. Granted is a boolean. If it is true, if the user is holding the lock, if it is false, that means the user is waiting for the lock. This will tell you whether this particular entry is a victim entry or this entry is holding the lock. Okay. So this is the PG logs view. So there are some standard queries to monitor. Okay, some queries here. So like find the queries running more than 2 minutes. So it is a standard query. So what I am doing is, okay, I am, so I am just querying the PG stat activity. So no lock is involved because, I am just trying to find out which queries are running more than 2 minutes. Okay, what I'm going to do, PID, the user. Okay, so query start. So then, I'm just giving, so PG stat activity where, so this one, so 2 minutes interval. So, so what it does is, any query which is running more than 2 minutes, so greater than 2 minutes, so will be listed. Blocking and blocked queries. We want to know which queries are getting blocked and which queries are blocking them. So this is a very standard, the query. So for finding out the blocking and blocked. Okay. So here what I am going to do is so I'm going to query the what we say PG logs, okay, as blocked, PG stat activity, okay. So this is what the condition is, PIDs. Join PG catalog logs. Again, I am joining on the logs. So this is the query. So from where, I am finding. So for the current database, which guys have been locked and which guys have been locking them. So I can find out. So blocked query and blocked back and PIDs. So which queries are blocked and what are their PIDs? Who blocked them? So that this is the query I can use. So these are the three queries which are very useful for monitoring, so monitoring the logs in that particular database. So the log monitoring is for a particular database as a DBA. So if you want to monitor currently who is logged or who is not logged, so you have to connect to the correct database and then you have to run these two queries, this query and this query to find out. Okay. So that is about, the monitoring the logs. How to manage the logs, how to manage the logs. You can stop the query, so the blocked query, or you can terminate the session which is blocking. So generally we don't do as a DBA, we let unless and until the blocker is taking hours together to finish. So we may try to kill the current query or kill the blocker session itself. But until then, usually we don't touch. If they are, just a few seconds blocked, we don't touch. Okay, statement digest. So for those in from Oracle background, so they knows that statement digest, right? The Oracle tracks each statement, right? So each statement is tracked and statistics related to each statement which is executed on the server are tracked. Okay, Oracle is, Oracle has that ability built in. So it can track all the queries which are running on the server. It can identify all the queries which are running on the server and also statistics about those queries, like how many times they got executed and other details about that query. Correct? We don't have any equivalent in the Postgres built in. We don't have any built-in equivalent in the Postgres, so which provides such an information about each and every query which is ever executed on the server. So then how can we do that? So, there is a third party extension called as PG stat statement. So there is a third party extension called as PG stat statement. You can enable this extension. It is already installed, but it is not loaded and not enabled. You need to load and enable that. Okay. So then, it will track each and every activity or each and every statement. So which is executed on the Postgres. So it gives information similar to what Oracle provides, but not exactly same. So, it is trying to go to up to that level. Okay. So that is what, the statement digest. It is an extension. In Postgres, an extension means an add-on feature. So the originally the Postgres lacks that feature. So some third-party developer has, written so that feature, that feature, and it is up to the DBS to decide whether they want to use that feature or not use that feature. Some companies are very sensitive to third-party tools, right? So they are very sensitive to third party tools. They don't allow it. Some companies are okay. Anyways, Postgres itself is a third, not third party, but Postgres itself is a free database. So we can use third party tools. So, you have this perception. So anyways, there is a PG stat statement. So this is an extension which keep tracks of individual queries. So it will keep track all the individual queries which are getting executed on the Postgres. So that gives you more information about, the queries, how they are doing. So what is the statistics related to that query? So everything you can find from the statement digest. Okay, what you need to do is you need to create an extension. Okay. So also you need to preload the library also, PG stat statement. Okay. So then it will create a view for us. So that view contains so all the queries we have executed after enabling that. Let us enable that extension. So for Postgres database, I am enabling that extension. So create extension. So this is how you can create the extension. So once you create an extension, you can see there is a table called as PG stat statements. So this table, this view actually, it is not a table, it is a view. PG stat statements. So it has these columns. So user ID, DB ID, query ID, every query is given one ID. So the query itself, plans, how many plans it got. So how much total plan time, minimum plan time, maximum plan time. So, total execution time. So how much total execution time, minimum execution time and maximum execution time. So this tells you, so how much time usually it takes and what is the average time, that is mean time. Okay. It also gives you information about, the block hits. So how many times this query found the data in the shared buffer. Block reads, how many times this query has to read from the disk. Blocks dirted, how many blocks are dirted in the, what we say, buffer. How many blocks are written. So to the disk. So, so it will, what we say means, so it will show all this information. Okay. So it also tells you about, temporary block reads and temporary block written. That indicates whether any temporary disk file it is using for sorting operation. Okay. So that is what, that is all the information it shows. Okay. So So it will track all the statements, select statement, insert, update, delete, all the statements it will track and saves the information here. So one more table is also there. So when the statistics are reset, you can also reset the statistics. It will be there. So when the statistics are reset, these are all counters, right? So some point of time, you want to reset them. Okay. So this is about, the PG extension. This is, about, the PG stat statements extension, which is helpful in monitoring individual statements in Postgres. So it is up to the DBA whether to go with this extension or not go with this extension. So let us see what it has. Select star from, so PG underscore stat underscore events. So, right now we have created this, but it is not working. Why? Because, we have to load the preload library also we need to load. You need to create extension and you need to load the library. So what I'm going to do is I will show you how to load the library. So in the data directory, we have Postgres. So PostgreSQL.conf file, and in that, so search for shared preloaded. So shared buffers. Okay, dynamic. Okay. So you have a thing called as shared preloaded libraries. So uncomment this, and you write, so PG underscore stat underscore statements. Okay, this one. So make this change. It requires a restart. Okay. At PostgreSQL conf file. So grep. Okay. So this one also we need to do, apart from, enabling the extension. So then we need to restart the Postgres service as well. So because, this change requires a restart. So Postgres is restarted. So once the Postgres is restarted, it will start capturing that information. Now you connect PSQL-P5433. So, so select star from T1. So you have this query. So now you check the queries expanded, select star from PG underscore stat underscore statements. Okay, so that query is already captured. So an ID is given to that query by this extension. So it is giving total execution time. So it is a cumulative time of all executions. Okay. So it is a cumulative time of all executions, that is calls. So calls indicates how many times this query got executed. So total execution time, minimum execution time, and maximum execution time. And once you have minimum and maximum, you can find out what is the average time. So average time can also be the total execution time divided by calls. So that is also average time, right? So, you have all this information captured for that query. So you can make use of the PG stat statements. So to effectively monitor the individual queries, but it is a third party extension. So remember, it is a third party extension, but it is safe to use. So it is safe to use. So far, no security issues were reported. Okay. So that is about our monitoring lesson. If you have any questions, you can ask now. I'm taking that as no questions. Okay. So I'm taking that as no questions. So, so we do the backup and recovery lesson tomorrow. So what today we will do is, there is another lesson after this. So there is another lesson after this. So that is moving and loading data. So we'll do it today. It is not a big lesson, but it is a very useful lesson. So loading and moving data. Okay. So what I'm going to do is we will see, but before this lesson, so I will complete the partitioning, table partitioning topic. So table partitioning is not a very deep feature or very big feature of Postgres. So table partitioning, we have limited options for table partitioning. So, and we will know what options we have for table partitioning right now. Okay. Table partitioning is done differently in Postgres. So, so it is completely different than what you have in Oracle database. So it is completely different than what you have in Oracle database. So there is no comparison between table partitioning in Postgres and Oracle. So it is like, so this feature, table partitioning feature was not there earlier until version 10 of Postgres, we don't have table partitioning. So until then, what we used to do is we used to use the subtables. So as partitions, there was a workaround, but not a solution. So not a feature called as table partitioning. So in Postgres 10, this feature is added. So table partitioning feature is added. Actually, what they did is the earlier workaround, so they formalized the earlier workaround. So as a feature. So that is what the table partitioning we have today. So what we are going to do is we will see about the table partitioning. So we will do the table partitioning, then we will take a break and we will come back and we will see the lesson loading and moving the data. Okay. So just a minute. So let me pull up that partitioning. Generally, the database trainings does not include DBA trainings does not include the partitioning thing. So that's the reason this particular PDF does not have. And in Postgres, the partitioning is not a big topic. So it's not a very big topic like you have in Oracle. Even it is not comparable to MySQL's partitioning. So I'm opening one text file. So called as, partitioning. Postgres right now supports. So there are some things we need to learn about the table partitioning theory wise. So we will see what we have for table partitioning. Just a minute. So the table partitioning in Postgres is based on so you know the child table concept, parent child table concept. So that is inheritancy. So table inheritancy concept. So it is based on table inheritancy concept. So the table inheritancy is, so you will have a parent table. The table inheritancy is you have a parent table, so which may or may not have data. And then under that parent table, you will have the child tables. So you will have the child tables under that parent table. So many child tables you can have under that parent table. So not just two, but more than two child tables you can have. More than one child table you can have under the parent table. The column definition for child and parent table are same. In table inheritancy, the columns of parent table and child table are same. Column definition of parent table is inherited by child tables. Okay, it is not the data that child table inherit, but it is the table structure. The column definitions of the parent tables are inherited by each child table. So that means whatever columns you have in the parent table, the same columns you will have in the child table. So if you query the parent table, you will get data from all child tables. If you query the parent table, you will get the data from all child tables. If you query the child table, you will get the data of only that child table. Okay, only that child table. So each of the child table, each of the type child table have their own data files. So the data files of parent table and each of the child tables are different. They are not same. They don't share the data file. The child tables will have their own data files and the parent table will have its own data file. No data file sharing here. Column definitions are same between parent table and child table, but you know the data files are different. Okay, so this is what you know the table inheritancy. So this is what the table inheritancy is. So the same feature is exploited for the purpose of partitioning. So in table partitioning, Postgres table partitioning, so what they did is, so the each child table is a partition. Each child table is a partition. Each child table is a partition. Okay. So that is how in older versions of Postgres, like 9.4, 9.2, 9.3 versions of the Postgres. So what we used to do is, you create a parent table, you create child tables for that parent table, designating each of them as a partition. Then on the parent table, we used to write the triggers for insert, before update, and before delete triggers we used to write. And those triggers, okay, examines the data, and they used to perform the operation on respective child tables. They used to perform the operations on the respective child tables. The triggers used to do. The DBS or developers used to write the triggers to make this table partitioning happen in older versions of Postgres, which is less than 10. From version 10 of Postgres, so we have a declarative partitioning. There is no need to write triggers now for us. There is no need to write the triggers. So you can just create the declarative, like other databases, you can create the partitions. But however, remember that still it uses the same concept of, the table inheritancy. You have the child table, each of the partition is a child table, and you have a parent table, which is called as partition table. And that partition table will have child tables as individual partitions. And both the child table and the partition table have their own data files. They don't share any data files. Okay. So this is how the partitioning works in Postgres. So right now, three types of partitions are supported. So right now, three types of partitions are supported: range and list and hash. So these are the three types of partitions are supported right now. So right now we have a create, means we have declarative partitioning, that is we can create the partitions. Okay. Earlier it was not like that. We used to create the parent table. We used to create the child tables. So with inheritancy, you have to use that inheritancy class. So while creating the child tables, so, and after creating the parent and child tables, you need to write the triggers on the parent table. So that trigger used to perform the partitioning, means if somebody inserts a row in the parent table, the trigger used to look, okay, examine the data of that inputted data, and then it used to make a decision whether it should be inserted in the first partition, second partition, or third partition. So that is how, the table partitions used to work in olden days. Right now also it works almost same. Only thing is, as a DBA, there is no need for you to write a trigger now. So you can simply create a partition, a table. So one restriction about the table partition is you cannot partition existing tables. Okay, so so you cannot partition means you don't have a command to partition existing table. However, you can split the existing table into the partitions. So manually you can so copy the data into the partitions. You can do that manually, but there is no command like in Oracle. So or in MySQL, just you run the partitioning command. The existing table will be splitted into partitions, right? So we don't do have like that. So if you have an existing table and you want to partition it, so you have to take it like a project. Okay. And then you have to you have to, what we say means, so first you have to create an empty partitions, and then you have to, what we say means, copy all the data, okay, from the existing table to this partition table. So that is how you need to do right now. So you cannot just simply split an existing table. Okay, these are some of the limitations of the partitioning. So another limitation is we don't have much to do here, like reorganization, sub-partitioning. So I think 16 version is supporting sub-partitioning, so it is still under, what we say means, development. So, but right now we don't have any sub-partitioning. So we have only, what we say means, so main partitions. You have the partition table and its partitions, but we don't have any sub-partitioning yet. Okay. So these are some of the limitations we have for partitioning. So how we are going to partition the table is very, very simple. So even now we use the concept of, creating the master table, or the partition table. Okay, so what you do is you say create table name. So like create table name. So partition by range, and you have to give a column for salary, right? So this is what you are doing. Okay. And once you have created the main table, so you can, what we say, then create the partitions of it. So for the range partition, min val and max val literals are provided. The min val means, the minimum possible value which you can save in this particular column, and the maximum possible value which you can save in this particular column, which is also the salary the partition column. So you can use that min val and max val, so that two literals are supported, so provided for us. Okay, so you have to create the main table, that is partition table, and then you have to create the partitions, or you are creating the sub tables. So there is a special syntax for creating that. So when you are creating a main table, you are saying partition, and partition by either range or list, or what we say means hash. So depending on the column, so which partition is suitable. For example, if you are partitioning on salary column, obviously range partition is suitable. If you are partitioning on let us say job column, designation or job column, list partition is so suitable. So you are partitioning on the employee ID column, so in such case, hash partitioning will be suitable, right? So that is how you have to select, so which type of partitioning so you want to use. Okay, so if it is salary column, it is what we say means, range partition only. Let me create this. I think I cannot copy this. So I'm creating the main table, that is EMP, with three columns, ID, name, and salary. Okay. So let me clear this screen. So what tables we have right now is, so we have these four tables: orders, PG, stats, T1, and TBS. So I will create my partition table. So the table created successfully. So this table is created successfully. Then, so what I'm going to do is, so let me check. So what it got created. So deep, so the EMP table created, and the type is, it says partition table. Okay. So the parent table is designated as partition table. So then I need to create the partitions. So I need to create the individual partitions. So, okay, for that, I have given these commands here. So create partition P1 for employee. So this is the main table name. So partition table name for values from min value to 5,000. So this is what, so you have. So I am copying all these three statements at once and I will paste it there. So, and all three statements are executed. Okay. Now you check out, so what tables it has created. So now you can check out what tables it has created. So it will create three tables, P1, P2, and P3. Totally, we have four tables now. So the EMP is the partition table. P1, P2, P3 are, the partitions. But you can see there is no mention of these partitions, right? So, but partition table is mentioned. The parent table is mentioned as partition, but the individual tables are not mentioned. Now we will we will insert some data. So I have given some sample data here. So in the lab exercise, so we have, so some rows I am inserting, three rows I am inserting. So each of these three rows goes into those three partitions which we have created. Okay. So we are inserting in employee table. We are not inserting any individual P1, P2 table. So once you insert, so, you can query the partition table. So you will see all three rows. If you query the partition table, you will see all three rows. Select star from EMP. All three rows you will see. If you query individual table, select star from P1. So individual tables also you can query. So you will see the data of that particular partition only. So, you can treat these partitions as individual tables. You can treat these partitions as individual tables. So this is how the partition works in Postgres. Any questions we have regarding the partitioning? Okay. The only maintenance operation we can do with the partitioning is we can detach the partition and make it a independent table. You can detach P1, P2, P3. So you are removing that partition. So that will become an independent table. Okay. So that will become an independent table. If you have another table which is having the same structure as EMP table, you can attach it as a new partition. So detach and attach, these are the only two maintenance activities which are permitted right now. So detach and attach. Detach means an existing partition will be expelled, and attach means if a table is there, individual table is there, and which you want to add it as a partition, so as a new partition, so you can attach it as a partition. So these are the two maintenance activities which are possible for partitioning tables. So this is what we have for partitioning. If you have any questions, you can ask me. So otherwise, we are done with the partitioning, table partitioning. Okay, so I don't see any, any questions. So I assume that we are done with table partitioning. So we will take a quick break, and after break we will come back and we will start our session loading and moving data. We will finish this. So this will be today's last topic. So then we will go to the lab as usual. So this topic should take about an hour's time. So this topic should take in about an hour's time. Okay. So let's go for the break and come back from the break and continue the session. Already it is uh, s- 4, so 4 past 4 p.m. So, we will take our break till 4:20 p.m. So 15 minutes break we will take. Okay. So see you guys at 4:20 p.m. So I'll be mute during this time and I will be away from desk. hope everyone is back from the break. So now we will discuss about so moving the data. Sometimes what is needed is we want to move the data from production to the what we say means test environments, UAT environments. The developers require production copy of the data for some testing and all those things. Or sometimes we need to move the data from production to ETL environments, so where the what we say reports are generated, data mining or data. So the reports are generated, so reporting tools and all. So the data has to be moved from the production servers to other locations. Okay, so we should be able to perform this. Okay, we should be able to provide a copy of the data, production data, to development environment, test environments, to the testers, to the developers. Or we should be able to provide the production copy of the production data to other teams which want to create, generate reports, or perform some data mining operations on this production data. So that is where the skills what we are going to learn in this lesson will be helpful. So whatever skills we are learning in this lesson will be helpful. So it is loading and moving the data. So how can we load the data and how can we move the data from Postgres to other Postgres instances, or even altogether other things also. Okay. So we will see that in this loading and moving the data. So the techniques are the things what we learn here appears to be like a backup. We are taking a backup and we are restoring. Obviously we are doing that, but it is not a backup. Okay, it is not a backup. So this backup has no traces, nothing. So it is not a backup and you cannot perform any kind of recoveries. So using this backup. So you should not use it as a main backup solution. So this is where move the data from production environment to, let's say, the testing team or development team has requested the production data. So you can provide. Sometimes they are more specific about a table or few tables they want the data from. They don't want the entire data. So they say we want only the data from the sessions table or so and so table. So we should be able to provide the data what they have requested. Okay. And sometimes they may want data of an entire database, like they want a data from our employees database or DVD rental database. So we should be able to provide that entire database data, a particular or few tables data as needed. We should be able to provide. Okay. So how we are going to do that is, so we have a concept called as SQL dumps here. SQL dumps are very useful in copying the data, copying the data from production servers to other Postgres environments. Even sometimes from production Postgres server to other environments, other database environments also. You should be able to what we say means. So you should be able to, okay, migrate or copy the data, okay, using the logical dumps. So logical backups, they are also called as backups. I have seen many people mistake it for backup. They take it as a backup. I have seen, practically I have seen some companies I did consultancy for, so they use as their main backup mechanism this one. So the SQL dump they use as main backup mechanisms also. So that is okay, but it is not a backup solution. It is only for good for moving the data from one Postgres to another Postgres. So these are only helpful in moving the data from one Postgres to another Postgres, but not to perform the backups and recoveries. Okay. So what options we have here in the logical backup is, so there is a command called as pgdump. So this utility so provides, allows us to, take a copy of the table or take a copy of entire database. So it will generate a plain text file with SQL commands. So it will generate a plain text file. Default is plain text. So if you want, you can generate it in tar format and custom format also. But by default, it is plain text file. Okay. So that is PG dump utility we can use to what we say means so copy or export the data or dump the data. Okay. So like in every database provides this, like uh, so Oracle also provides the logical dumps, right? Data dumps. So same way here in Postgres, some data dumps are there. MySQL, if you are familiar with, so MySQL dumps are different. You can perform, so that act can be that can be used as the main backup also. So only for MySQL, so dumps or logical backups are useful as main backups also. But other databases, so we should not use logical backups as main backup solutions or main backup strategy. So this is only ad hoc request. Somebody requested data from production to the test environment, so you can use pgdump. Okay. So somebody requested the data from a particular table from production to some other environment, so you can use this pgdump. Okay. Or regularly you want to copy the data from the production database to a analytical another Postgres server where data analytics are performed, so you can use these dumps in such case also. Okay. So these dumps are for that purposes. They are not the main backup strategy. They are not the backup solution. So this PG dump utility we can use, and this will export, or this will dump the table definitions, and it will also dump the data as well. So you can also what we say means be partial, like you can dump a particular table or few tables. You can dump a particular schema, all tables from the particular schema, or all the tables in a database. So you can be selective about what you want to dump. Okay. So PG dumps are internally consistent, and the PG dump does not cause any issue to other users. So while the PG dump is running, other users can carry out their own what we say means operations. What the PG dump does is, when you start PG dump, it starts a repeatable read transaction for itself. For itself, it will start a repeatable read transaction, and it will then work, or then it will read the tables in the repeatable read transaction. So that gives the PG dump a consistent snapshot of the data throughout the dump time. So it might be 5 minutes, or it might be 10 or 20 minutes, it might be 1 hour or 2 hours. So the PG dump will be able to still see the same data what the table got when it started. Okay. So it will do a repeatable read. So it will start a repeatable read transaction for itself, and within that repeatable read transaction, it will start reading the tables. Okay. So that's the reason the dumps are the PG dumps are internally consistent. So whatever dump you got, it is very, very consistent. Okay. So that is what the PG dumps are. So the some of the options of the PG dump is, so you can be more selective when you are using PG dump. You can be very selective about what to dump. You can dump just data, So for example, you have a requirement that, every night from the production table, the data has to be copied over to a Postgres where data analytics are performed. So every day, just you need to copy the data only. So you don't need to copy all the table structure and other things, you need to copy the data. So, you can do the data only. Okay. So it will not dump any table definitions. It will dump only data definitions here. Okay. So it will dump only the data definitions. Sorry, data only. So S means schema only. For example, the developers generally they will create the tables for a new application in a test development server. So they will create all the tables. Maybe it is a 1 month or 2 month process when the application is being developed. But once the application is ready, so they want the same schema from the developer machine to be deployed to test UAT or production machines. Or sometimes, the table definitions are there in the tables are there in the test machine, and it is time to deploy the same database in the production server. So we don't, in such cases, we don't want the test data, right? We want all the table definitions. We want the ownership of the table definitions, column definition, constraints, and whatever other things it got. But we don't want any data from the test to be migrated to the, production server. In such case, you can choose schema definitions only, dash S. Dash A means data only, no schema definitions. Dash S means schema only. Only the table structures is dumped, not the data. So it is particularly useful if you want to migrate, if you want to take a copy of the uh, database structure from the development server and deploy it to the production server. So you don't want the data which is used during the development phase, right? You want blank tables to be created. So schema definition, okay, and that is data definition only. That is only the create tables. Empty tables are so copied over. Schema. Sometimes, we want to dump the tables from a particular schema only. So we don't want public schema. We just want to dump the tables from a particular schema. That is, the N. So give the schema name. The tables from that schema will only be dumped. Other tables will not be touched. So if you want to dump a particular table, you can also be specific. So you can be selective about which table to dump. So you can be selective about which schema to dump. You can be selective about whether you want to dump only the table definition or empty tables, or you want to dump only data without table definitions. So you can be, specific, or you can be selective about what you are trying to do here. Okay. So then, so where to save the dump? So whatever, the dump is created, that must be saved in a file, right? So that is dash F option. So gives, tells pg dump to save it somewhere. So dump has, format also. So there are three formats supported: plain text format, tar format, and, compressed format, FC, or custom format, not compressed, but custom format. So three formats are there. The default is plain text format. Okay. If you want, you can go to the custom format. You can go to the tar format. So you can go to that formats. Okay. So use OIDs. Don't use table names or object names. Instead of use OIDs. So that option is also there. So, but always use the table names only. So because otherwise, when you are restoring, so from the dumps, So you require those OID tables with the same OIDs to be present. Okay, these are some of the options we have for the dump. So let us do some dumps, right? So once you have dumped, let us say you took a copy of data on the production server and you send that file to the test machine or development machine. So how we can restore that? So you can simply say the PSQL, the command PSQL, the database name, and less than symbol, and that PG dump file. So whatever file you have used PG dump, so just give that file name here. So it will be restored. That is as simple. Okay, apart from that, you also have PG restore command also. Okay, for plain text dumps, so this is the option. For other formats like tar and custom format, you need to use PG restore. These dumps can also be performed from PG admin also. So these dumps can also be performed from PG admin. From PG admin, you cannot do the backups, but you can perform these dumps. So, so PG restore also has options. So database name to connect. Okay. So, and also, in the same database, it will also restore that. Uh, so if you use the -c option, so it will create a new database also. So if you want to restore this dump into a new database, you can use the C option and you can create on fly. It will create a new database and restore the dump in that database. So while restoring, you can also be choosy, like, you restore data only, not definitions. Restore schema only, no data. So only empty tables restore. So restore a specific table. So you can be selective. So when you are restoring, you can restore one particular schema also. So you can be selective while restoring. PG restore gives that option. Okay. So PG restore works with, tar format dumps and custom format dumps, and PSQL, this method, so works with plain text dumps. Okay, so what we will do now is I will show you so how to take the dumps. Okay, so what I'm going to do is I'm going to create a directory here because we require a directory to save the backup output. So I'm creating a directory called as dumps. So my directory dumps is there. So whatever dumps I am doing, I will save it. And later on from this dump directory using a CP command or something, I can copy, okay, these files to the target location. But while taking the dump, I will save them into the dumps. Okay. So the command is, so this is the command in the bin directory. Okay. In the bin directory, the pg dump is the command. So I will take a dump now. I will, dump. So I will dump the Postgres database. I can dump MyDB database, whichever database I want. So let us dump always one database at a time. So PG dump. So database is Postgres. Okay. So database, I'm dumping Postgres database. So I want both schema as well as data. I am not very selective. I want all schemas. I am not selective about schema also. I want all tables. I am not selective about table also. So I am giving the file name. So I am saying, where live PGSQL, okay, dumps. And the file name which I am giving is, Postgres dot, okay, dump dot SQL. So the long file name I am giving. So the dot dump is to identify this is a dump, and dot SQL is it is a SQL commands are there. So simply run this command. So it will dump the entire Postgres database. So we need to give our custom port also. And if required, username and password. Right now I'm using Postgres user to dump. So it has dumped. Okay. So it has dumped, but there was no progress report, right? So there was no progress report. So it did it quietly. So if you want, messages, you can use option, verbose option you can use. The verbose option generate a lot of messages on the screen. So, let us check whether this file got created. It got created. So let's go into the dumps directory. So you have this file. So it is about, 4408. So about 4 kilobyte file it is. So 4.4 kilobyte file it is, right? So this is how you should be able to verify the size of the dump. So, okay, what is there in that file? Less. So dump.sql. So it has a plain text SQL commands it will have. So the lines with starting with two dashes are comment lines. So what it is doing, sales schema. So we have a sales schema here. Create schema sales, alter schema sales to owner. So, the extension is also done. So because we have an extension here, so create extension. So PG statement, okay, owner. So then, you have, the create table. So for each table, you have the create table statement. For each table, you have create table statement. Then it also say it is also setting the owner of the table. So you have all the SQL commands. Okay. So that's the reason, the dump taken in one version of Postgres is also compatible in either higher versions or lower versions. Okay. So first it has, restored those tables, and then it is attaching them as partitions, you can see. So P1, P2 tables, so it has been restored as individual tables. So you can see here. So P3 table is created as an individual table. Create table P3 ID integer name. So with same columns, it is created as an individual table. But later on, what it is doing is it is attaching it as a partition. Okay, those individual tables are getting attached as partition. So this is what the plain text dump is. So for a database Postgres, let us do some dumping for our MyDB also. So MyDB database is MyDB. MyDB. So here also you give the database name as MyDB. So because I want to dump this MyDB, so it is also done. Now, okay, now that we have this, let us also check. So its size is just 934 bytes. So not even 1 kilobyte. So let's see what is there in it. So same thing. So SQL statements. So it also have a custom schema, SCART. So first schemas are created. So then, it will go on creating the tables like T1. So in the SCART schema, SCART.T1 means schema name dot table name. So and is where it is dumping the data. So the T1 table is empty, so it does not have any data. So that's the reason after copy command there is no data at all. Okay. So if you look into the Postgres, so you will find the copy command with the data. So you see P1 table, so one row in it. P2, P3 data for T1 table. So this is all the data in T1 table. So the copy command is responsible for importing the data. So here the data is getting imported. So because we clustered that table, so it also included that cluster also. Okay. So this is what how the dumps are created. So for example, what we do is we will log in. So we will do something nasty. So PSQL. MyDB. So two schemas are there. So I will just drop that schema. Drop schema scar. Okay, the table is there, right? So I need to drop the table. Drop table scar.t1. Then drop schema. So this table became, completely, this database became completely empty. So just I want to restore from it. You can also restore in a different database. It is not necessary that you should restore in the same database or in the same server. You can take that file and you can restore it somewhere else also. So then what I'm going to do here is I will restore from that dump. So how can I restore from the dump is if it is plain text dump, I have to use PSQL. 5433 is the port. Database is MyDB. So then I have to say, uh, so so mydb.dump.sql, that file name I am giving. So it is done. So it is done. So this is how I can restore. Okay. So I can just verify it. So I can verify it by logging into here and you say DN, you have your thing and you don't have tables here, but you can see the tables by setting the search path, right? So search path is equal to, so what we have is public comma start. So now you do D, so you also have the T1 table. So that got restored. So this is how you can restore. So maybe not be generally we don't restore on the same server like I did. So we restore on a different server on a different database. Okay. Any questions here? So I'm taking that as no question. So I will insert some data in it. Insert into T1 values 10, comma 20, comma 30. I can also generate a series of numbers. 40. So select start from T1. Okay. So now we have some data also. So we will do some experiment here. Exit from here. We will dump using. So we will dump using what we say means uh, custom format. So what I'm doing here is I'm using a custom format, capital FC, custom format. And I'm saying MyDB custom dump. Okay. So the file name is MyDB custom dump. Okay. So, so we have this file, you can see. So the custom dump is so the custom dump is 1.6 kilobyte. It took more space. Okay. Then the plain text dump. So, but what we have in the custom dump, let's say MyDB. So custom dump. So it is saying it is binary file. Do you want to see it anyway? So you can't see anything here, right? So that is what the binary file is created. Okay, if you don't do custom dump, it is a plain text file. So now it is a binary file, so people cannot see the data. Okay. So that is the advantage we get with the custom dump. Okay. So we will do the same thing. So we will delete that schema in table and we will see how we can restore from custom dump. So because the method is different here. So I'm connecting to the PostgreSQL and I will do the same nasty things. So I'm saying drop table start.p1, drop schema start. So I don't have any schema. I don't have any table. So, this is what again, I can restore it from my custom dump, which I did earlier. So what I can do here is, so exit. So I can use the pg restore command. So I need to use the pg restore command to restore from formatted dumps like tar format or custom format. FC or FT I need to restore using the pg restore command. So this is the pg restore command, option and backup file. So the database name. So you want to create a new database, you can also do it. So restore data only, restore a particular schema. So restore table, you can be selective about, which schema, which table. So, by default, just give the database name and, backup file name. So it will restore. So let me restore it. So PG restore P5433. So D is my DB, database is my DB. So the file is, so custom dump. So this is the file from which I want to restore. So it has restored. So you can check out. You can verify from here, right? So you can connect to PSQL and you can verify it. See, select star from start.p1. Okay. So everything is restored. So that's what you get with the pg restore command. You can use if it is a custom or tar format dump. If it is a plain text dump, use PSQL command only. PG restore does not help there. Any questions with PG dump? So I am taking that as no questions. So moving forward to entire cluster dump. The PG dump which we have learned now, so it dumps only one database at a time, only one database at a time. But if you want to dump the entire cluster, including the definition of global objects, so you can use the SQL dump all, PG dump all command. So PG dump all command is very useful to take the entire cluster dump. Okay. So what options you have? The same options only, like A means data only, S means definitions only, G means global objects only. Global objects are what? Table spaces and what we say means users. Of course, the database is also global object, but this does not include the databases. Okay, it only includes the users and what we say means table spaces, not databases. Okay, out of three global objects, it will export only two here if you give G, global objects. If you want to dump only roles, so if you are performing a migration, you are migrating the PostgreSQL server from one machine to another machine, so another server. So the very first thing you want to do is create the same users on the new target machine, right? So that is you can dump only roles, only users will be dumped. Okay. So skip restoration of object ownership. So if you don't want to retain the object ownership, you can also use O option. So object ownership is not what we say means retain. So at the time of restore, whichever user is restoring, that user owns the object. Okay. Do not dump the privileges. Generally, the privileges granted by grant and revoke per object will be, dumped. Either PG dump or PG dump or both the dumps. So if you don't want that privileges, so you can also what we say means use dash X. Okay. So So generally, when you restore, generally it is you are just executing those commands, right? So you are executing those commands. The copy command is like insert command. Okay. So the triggers, if there are any, will fire automatically. Okay. So you want, sometimes we don't want the triggers to fire. Okay. So you can disable the triggers. You can use option disable triggers. So n- this will disable the triggers at the time of restoration. Okay. So these are the options we have for dump all. So we will check this option, R option we will check. Okay. So roles only dump. So how we can dump the roles? So PG underscore dump all dash P5433 dash D Postgres. You need to give one database to connect, even though we are not dumping any tables from the Postgres database, but it should connect. As I said, every connection is targeted to a database. So you should give what database. So Postgres generally, so in our lab setup, even if you don't give that database, it will connect to the Postgres database only. Okay. So I am saying R. Okay. So file roles.sql. Okay. Oops. Okay, you don't need to give. Actually, we are not dumping any particular database. So you don't need to give this option. So it has dumped all the objects. We are not dumping any database so in particular. So there is no need to mention the database. So you check out what it has dumped here. So you can say less roles.sql. So you can see it has created including the password. Including the password is dumped. Okay. Including the group membership, role membership is also dumped. Okay, the same thing I want to do with for global, all global object. Instead of R, I want to use G. So, table spaces, if any. So, so I'm saying global.sql. So let us see what it does for global.sql. So first of all, it is what we say means dumping the roles, because roles is very important. Even table spaces are owned by roles. So once it has completed the roles, role membership, etc., now it started table spaces. Only one table space is there, and it has so created the definition of that particular one table space. Okay. So this is how you can dump the global objects. Okay. So how can you restore from PG dump is, PSQL command. So you can use the PSQL command, PSQL less than, so the dump file. So that's it. So that is how you can dump the, what we say means use the PG dump and PG dump all to move the data from one Postgres server to another Postgres server. Because it is in SQL statements, most of the time these statements are also compatible between the different versions of Postgres. Like, Postgres, so 10 to 12 or, 14, 15, the SQL statements are pretty much same. Rarely we see syntax changes in the, what we say, SQL statements. The next thing in this topic is exporting the table data to CSV file. Postgres provides a copy command which can be used both to export the table data to CSV file and import the data from a CSV file to, the table. So this copy command can be used for both purposes. For example, if you want to export, so what you are doing is you are saying copy the table name to, and the file name. There are some options you are giving, like with the CSV. So you are giving the format CSV. If you don't give the CSV format, it will use tab separated format. Delimiter is comma. So the column delimiter is comma. So the null values are written as nulls. So the quotation is double quote. Okay. So these are some of the extra options I am using here. So this is how you can export the table data. You can use the export command, a copy command, to export data from a table to a CSV file. So the same command can be used to import the data. So from, a CSV file to a table. Let us say already I have data in this CSV file, and the columns and data types are matching. So when you are importing, you have to check whether, whatever the columns in that CSV file, okay, and the data types, so they are matching to the table. Okay, if it is so, so you can use the same copy command, copy emp. This time we are using from. So while exporting, we have used to, now we are using from. So, the same options. So the CSV file name. So with the CSV delimiter, so, whatever is there according to the format used in that file, use it and it will import it. So while exporting as well as importing, you can make a column selection also after table name. So here in example, I have not given the column selection. However, you can make a column selection also. So you can put a comma here. You can put a, what we say means, so you can put a bracket, and in the bracket you can give comma separated column names. So for only those columns are either exported or imported. So that is our, copy command to export the data into the CSV file or import the data from CSV file. This exporting and importing the data from CSV file to CSV file is very important. For example, you have some table in Oracle database and you want the table data to be migrated to the Postgres database and you don't have any tool to do that. Okay. So how you are going to do it? So simply what you are going to do is, so you will export, Oracle also has the facility to export the data in CSV, right? So tab separated and CSV, you use that and export the table data to the CSV in Oracle and then bring that file to the Postgres server and using the copy command import it here. So this is how you will manually, you can migrate the data from any database to any database. Because every database has a mechanism to export the data to either tab separated or CSV files and import the data from CSV files or tab separated files. So if you don't have a tool to migrate the data, you can always rely on that CSV, so data import and export. It is not very, it is efficient method. There is no doubt about the quality of migration. However, it is time consuming if you have large set of data. So the tools can do quickly for you, but if you are doing it manually, exporting there in the CSV and importing in Postgres using copy command, it takes some time. That is the only thing, but still. Any questions here? So I will export one file and I will show you. So let me connect to our Postgres database here. You can try with employees database. I didn't restore that employees database. I should restore it. So what I'm doing here is, so PSQL. So I'm connected here and I have this database select star from T1. Okay, this table, T1 table, I have some data. I want to export the T1 table. So I want to export the T1 table to CSV file. So what I'm going to do is copy command, copy T1 so to where live PGSQL. So T1.csv. Whichever directory you are giving here, that directory should be writable to the Postgres user. Okay. That directory must be writable to the service user. With CSV, delimiter is comma. Okay. And so what other options we have? Null is null and quote is double quote. So anyways, we don't have any null values in this table. Option I am giving. So null is replaced with the word null and quote. Quotes are quote. Quote. Quote is double quote. Semicolon. So it is a SQL command. It will run and export the T1 table to CSV file. So, it has done it. So you can also give selective columns also if you want. So if I want, I can just give a particular column. What columns we have? Name column we have. So I want to export only names or a list of columns you can give. Okay. So see, so selective columns also you can do. Okay. So let me exit from here. So, so I'm in dumps actually. So you can see this t1.csv, t1.csv. So, this is how it has exported. I will connect to MyDB. I'll connect to MyDB. MyDB. So we don't have a table. I will create a table. Create table. Okay. Test ID, integer, name. So varchar of 20. So this is an empty table I have created. Select star from, test. So there is nothing in it. So what I will do is I will import that CSV file which I exported earlier. So what I'm going to do is I'm going to use the same copy command. So instead of same copy command. So instead of what we say means to, so I'm going to use from. And instead of T1 table, it right now, I'm importing it in test table. Same copy command I am using. So only difference is instead of to, I am using from. Okay. So this is how you can import a CSV file. So into the table. So now you check whether the data is there or not, and definitely we all know data will be there. So it is there. So this is how you can import a CSV file to a table and export a table's data to a CSV file. Any questions? This is the technique. This is very useful, especially during the migrations. I have used it a lot of time. From any database to any database migrations you can do, because every database provides a mechanism to export the table data to CSV file. So if you have time, you can always do it. So using this method. Okay. So that's about for today's session. Tomorrow, day after tomorrow, we have important sessions like backup. Tomorrow we will see about the backups. and restores point in time, restores everything, whatever is built in into the Postgres. Day after tomorrow, that is Friday, we'll see about, the barman. So barman tool. So how to perform the backups using barman tool. So we will see it on day after tomorrow, that is Friday. Okay. So that is the agenda for rest of the week. In between, the barman, so, usually it takes about 4 hours to complete because you need to do installation. So sometimes, we may be able to do it early also. In such case, we may take up some other topic on Friday. Otherwise, it is dedicated to barman only. So tomorrow backup recovery, point in time recovery, 4 hours. So, it fits into 4 hours. Okay. So that's all for today. So we will go to the lab now. We'll do the lab. So we have 40 minutes for lab, actually 39 minutes for lab. So what you are doing in the lab is, So this is what, and from the running roast, you also use those, check those parameters and commands from our monitoring lesson. So I'll be at desk. So I'll be at desk. So if I'm moving out, I will inform you guys. So I'll be at desk, but I will mute myself. So there could be some delay in response.